Have you ever watched a real expert at work? A doctor, a mechanic, an artist, and you just think to yourself, how on earth do they see that? It's like they're tapped into a different reality, one that's packed with all these details and patterns that are just invisible to the rest of us. Well, today, we're going to pull back the curtain on the fundamental brain process that makes all of that possible. This isn't a new puzzle. Over a century ago, the psychologist William James absolutely nailed the challenge our brains face from the second we're born. He said the world is just a blooming, buzzing confusion. And he's right. Our senses are getting hammered with this chaotic storm of light, sound, and raw data all the time. So the big question is, how do we get from that blooming, buzzing confusion, to a world that makes sense? A world of separate objects and clear ideas and meaningful patterns. How do we find the signal in all that noise? Well, it turns out the answer comes down to one single, incredibly powerful mental move. And that move is called differentiation. Think of it as your brain's master tool for carving up reality. It's the process of taking a big, blurry general category and splitting it, slicing it into smaller, sharper, and way more useful ones. This isn't just about sorting things that are already there. It's about actively creating new distinctions where, for you, none existed before. Now, to really get how this works, we've got to start at the ground floor, our senses. How does your brain actually learn to see or hear differences that were totally invisible to it just a little while ago? The brilliant psychologist Eleanor Gibson had this totally revolutionary idea about it. She argued that learning to see isn't about, adding new facts on top of a blurry image. No, it's about your brain getting better at finding the patterns that don't change, the invariants, she called them, that were already hiding in all that sensory chaos. It's about learning to spot the stable structure underneath the noisy surface. And our perception is really shaped by these two incredible forces. They're like two sides of the same coin. On one side, you have differentiation, splitting. This is when one big category becomes 2 or 3 or 10. A novice tastes red wine. Simple. But an expert's brain has split that category into Merlot, Cabernet, Pinot Noir. But at the exact same time, your brain is doing the total opposite, unitization, or lumping things together. It takes all those individual letters and clumps them into a single chunk, a word, that you read instantly. It's this constant dance between splitting things apart for more detail and lumping them together for more speed that makes us smarter. So how does this actually happen? What's in the brain's toolkit? Well, first we've got differentiation, which we've been talking about, splitting one thing into two. Then there's attentional weighting. This is all about learning which details actually matter. A botanist learns to ignore the color of a leaf since that changes, and focus on its shape, which doesn't. And finally, there's stimulus imprinting. This is wild. It's where your brain literally develops new specialized detectors for important patterns, like learning to hear that subtle phonetic click that separates an R from an L when you're learning a new language. Okay, so our senses are getting sharper. That's the first step. Now let's move up a level and see how these new, sharper perceptions let us build and totally rebuild our whole understanding of the world. The legendary psychologist Jean Piaget gave us this idea of schemas. You can just think of them as mental blueprints or file folders that we use to organize everything we know. So a little kid has a schema for a dog. It's got 4 legs, it's furry, it has a tail. It's a pretty useful blueprint, until of course reality throws a curveball that the blueprint just can't handle. And this right here is a perfect little story of how we learn. First, we try to cram the new thing into an old box. That's assimilation. The child sees a cat, points and yells, "Dog." But then comes disequilibrium, that moment of confusion. The cat meows instead of barking. The blueprint is wrong. And that feeling of conflict is the magic moment. To fix it, the brain performs accommodation. It changes the old dog schema and creates a brand new cat schema. And here's the kicker. Accommodation is differentiation. It's the mental act of splitting one category into 2 much more accurate ones. So we've gone from what we see to what we think. Now let's go all the way down to the wiring. What is physically happening inside your skull when you make one of these distinctions? And this is so important to really let sink in. Differentiation isn't a metaphor. When you learn to distinguish something new, your brain is physically rewiring itself. It's a literal act of biological sculpting, creating clarity by carving away all the unnecessary noise.
So how does the brain do its sculpting? Well, funnily enough, it uses intelligent inhibition. It quiets things down. On a tiny scale, when one neuron fires, it actually tells its neighbors to shut up. That's called lateral inhibition, and it makes the signal way sharper. Then, on a bigger scale, you've got your brain's CEO, the prefrontal cortex, which is actively filtering out distractions. And it knows what to filter because another part, the brain's conflict monitor, sounds the alarm whenever our old mental maps don't match reality, signaling that a new distinction needs to be made.
So we've seen this mechanism at every level: perception, concepts, and neurons. Now let's zoom all the way out and look at the absolutely stunning result of this process when it's repeated over thousands of hours: the creation of an expert. This right here, this is the fundamental divide. When a novice looks at a complex problem, they get stuck on the surface features, the superficial stuff, the way things look. But an expert, after years and years of differentiation, has learned to see right through all that to the underlying principles, the deep structure that's actually running the show. And this table really lays out the whole journey. A novice has this jumbled pile of isolated facts. Their brain is working overtime just to figure out the basics. It's exhausting. But an expert has built this beautiful, highly interconnected web of knowledge. And because they've made so many fine-tuned distinctions, they can pull up these huge, complex chunks of information automatically without even thinking. It frees up all their mental horsepower to focus on strategy and creativity because the hard work of differentiation is already done. What does that actually look like? Well, think about a chess grandmaster. They are not seeing 32 separate pieces on a board. No way. Their brain, after thousands of hours of this differentiation process, has learned to see over 10,000 meaningful patterns, chunks of strategy, of attack, of defense. They are, quite literally, playing a different game than the rest of us. That's the expert's edge. So the ultimate takeaway here is that differentiation isn't just something that happens in your brain. It's the very engine that builds your reality, one distinction at a time. Every single time you learn to separate what was once all lumped together, you are upgrading your ability to see the world with more clarity, more precision, more power. So the only real question left is, what crucial distinction will you learn to make next?